we're going to hopefully discover a few things.
Okay.
Okay, first of all, we want to draw our attention over here. Tell me something about those two.
Ooh, one of them's hot, I can tell you
One's
that.
hot. Is it
This
really
has got
hot?
Yeah, it's hot. Feel
Okay.
of it. It's real hot.
Oh, it's not hot.
It certainly
And that-
is hot.
And that one is cold, right?
I'm a more sensitive person.
Well,
than
you are very sensitive.
This is cold water. I assume this is just water.
That's just plain water, okay?
Okay.
And this is nothing but food coloring,
Okay.
okay? And I'm going to put 1 drop of food coloring into each one, and we're not going to stir or shake.
Okay. No stirring and shaking.
And then we want to see if we can notice any difference. And it'll take, you know, a minute or two, and so we wanted to start that early on.
Okay.
But we want to see if there's a difference in the mixing of cold water and dye and hot water and dye.
Okay.
Okay. And so, can you tell a difference?
Yeah, I can. The hot water is mixing up a little bit more than the cold water is. The cold water is going right to the bottom.
Okay, most of it sank to the bottom, right?
Yeah.
And
that's the cold water.
right.
This one's cold.
And it looks like to me the dye is mixing a little faster in the hot water.
It is.
Would you agree to that?
And swirling around a little bit more.
Okay.
Okay.
All right. So what we're thinking now is that there's something different about hot water and cold water that makes it mix faster.
Okay.
Okay.
The
You got any
little
ideas there?
molecules
Okay.
are swirling
Now,
around in there.
Here, we'll put this over to the side a little
Okay.
bit, and we might
hot
come
and
back
cold
to that.
we're moving
Okay.
over.
Now that's cold water.
Cold water.
This is hot
Now,
water.
there's something in that one.
Yeah, this has a red food
Red food
coloring,
coloring.
and we can remember it's hot because it's red. It's
Okay.
red hot.
All right, red
All
hot
right. And the trick is I need to fill that all the way up.
to the top.
Okay.
Okay.
And then this is cold also, and this is going to be hot.
Okay.
Okay.
2 hots, 2 colds.
Okay. Now what we're going to do is place one of these bottles upside down on top of the other one.
Now, that's the part that I have to do, and I'm not happy right there.
Without spilling it. Okay, pick a card, Dave, any card.
This is the card right here.
All right. So we're going to do this with an old cheap playing card. Let me do one first.
Okay.
To
Cold, hot.
Okay, now I'm going to
Cold,
put the hot one on top,
Okay.
and you're going to put the cold one on top. Okay?
So-
And let me show you. You're going to slide your playing card.
Now, get close on this,
Okay.
guys.
All right?
Okay.
And then you invert, and nothing will spill.
Maybe.
And then you slide that card on there, and then you want them matched up pretty closely.
Okay.
And we're going to leave it just like that for a second till you get yours ready.
I'm going to put the cold one on top.
Right.
Bill, the potential here is for this to be a big mess.
Well,
I can tell you.
I have confidence you're going to do this.
Oh,
Okay, there you go. Now,
already spilled a little.
all right, you want to match them
How
up a
am I
little
doing?
bit. You're doing great. Now,
I've
just-
got them matched
now,
up.
what-
Now, the cold's, wait, mine's
what-
leaking.
okay, it's all right. It's all right.
Cold's
now,
on top.
What
hot's
I'm
on
going
top.
to do now is slide the card out. Okay,
Right.
I'll show you how
Okay.
it's done. And when you pull the card past the edge, you can tell if they're going to match up.
Oh, yeah, I can see.
Okay?
I'll hold this one.
Now, a
make it
little
still.
bit might spill,
Okay.
but not a lot.
Okay.
Okay.
Ooh.
All
Now,
right.
wait a minute.
Now, what's happening?
The hot's staying hot, high.
Okay.
The
They're
heat
not
rises.
mixing. Okay, they're
Heat
not
rises.
mixing very much.
Okay.
Okay. Now,
Okay.
we want to see what'll happen when you slide your card
I
out.
tell you, what if you slid my card out?
Okay.
Yeah.
All right.
I've already done the hard part.
Okay.
Okay.
All right, here we go. Are we
We gotta
ready?
Compare the two. All right. Get this one in the shot, too. They
Okay.
really react differently.
All right. Now, what would you say you're observing here, Dave?
I would say we've always heard that heat rises and that cold doesn't
In the
rise.
air. That's in the air, right?
Okay.
And that seems to also be true in water.
That's
right?
really interesting. Look,
Okay.
doesn't mix
All
up
right.
at all.
Now, so we've discovered something about hot water. Hot water will rise through cold water.
Hot water will rise through cold
Okay.
water, but
Now-
cold water won't rise through hot water.
Now, what does that tell you about hot water?
Hot water is less dense.
Less dense. Okay. So, we've discovered a couple of amazing things here.
What?
That hot water, the dyes will mix much faster
In
than
hot
with
water
cold,
than in cold
than in
water.
cold water.
Okay.
All right. And that hot water is less dense than cold water, and that's why the two liquids did not mix here, but they did mix quite rapidly
that's
there.
really very interesting. Get that shot one more time, guys.
Okay.
This one never has done a thing.
Right.
The hot stayed at the top, and then this one, the two mix very quickly.
Okay. Now, your job as a scientist, Dave, is to explain why we made these, why we see these things.
I can't do that.
Okay. Well, now it's making observations like this
Okay.
that led us into the current theory of the structure of matter.
Okay.
What do we think, what's the smallest amount of water you can have?
A molecule.
A molecule, okay? So the way we explain this is that water, and in fact all matter, is made of very tiny particles. And for water, the smallest particle is called a molecule, okay?
Okay.
And another thing we can say here, it must mean that when water is at a higher temperature, the molecules move faster than when
And
the
we
water
saw
is at a
that-
cold.
we saw that when
Right,
it-
and
when
we
it
saw
mixed it.
evidence of that when the dye mixed
When
more
we started.
rapidly.
Now, there's one, we're about out of time. How much time we got? No time.
No time?
We're out of time. The other thing as a scientist we've got to demonstrate is how do you get these bottles off?
Well, we're going to do that off the air, Dave.
Oh,
Now, I'm just going to carry them over to the bucket and dump them in a bucket.
that was
Okay.
very interesting. Nice to have you here today. Again, you demonstrate very interesting things and things that teachers can use in their classrooms.
That's right, and this is something you can do at home with your kids.
Very
So-
inexpensive. Bill, thanks for coming today. We're going to take a break and try to mop up. We'll be right back.